and hello everyone. For the first cases, we're going to talk about chi-square test. So what is chi-square test actually? Chi-square test is a non-parametric test which is suitable for analyzing normal scale data. This chi-square test divided into two types, which is the first one is chi-square test for goodness of fit and the second one is chi-square test for independence. For goodness of fit, it is to analyze difference between independence categories of a variable. It consists only one variable, a single variable. Meanwhile, for chi-square test for independence, it is to analyze the relationship two or more categories of variable, which means it contains more than one variable, 2 or 3 or 4. For chi-square test, it contains 4 conditions, which the first one is the measurement scale is a nominal or ordinal. The second one is it a random sampling. The third one is the expected frequency for each category in the variable more than 5. And the last one is no subject measured more than once.
For the explanation for the chi-square question, there are 5 steps. For the first step, we need to state the null and research hypothesis based on the question. Next, we need to decide the alpha value, which is 0.5 for this question. The third step, we need to calculate the chi-square value using the table and also using the formula of chi-square value equals to sum of observed value minus expected value square divided by expected value. For the first step, we need to compare the calculate value and the expected value. We can find the expected value in the chi-square table against the degree of freedom, which is the number of categories minus by 1. Lastly, we need to make a conclusion either way the null hypothesis is accepted or rejected.
To answer this question, you need to state the hypothesis statement. For the null hypothesis, there are no differences in the predicted phenotypic outcome of the traits in a cross of tiger and cheetah. For the research hypothesis, there are differences in the predicted phenotypic outcome of the traits in a cross of tiger and cheetah. Next is calculation. The calculation consists of the table making. The observed value has been given, while the expected value can be calculated using the phenotypic ratio that has been given in the question, which is ratio 4:3 to 9. Next is to calculate the value of FO minus FE square divided by FE to get the observed critical value or X square. The calculated X square value is 4.72 as shown in the table. The expected critical value can be identified by using the chi-square distribution table. Here, we are going to use the degree of freedom of 2 and alpha 0.05. The expected critical value is 5.99. The end of our calculation. For the conclusion, the critical value from chi-square distribution table is 5.99, which is larger than calculated chi-square value, which is 4.72. Thus, null hypothesis will not be rejected. So, there are no differences in the predicted phenotypic outcome of the traits in a cross of tiger and cheetah.
Next, I would like to introduce about Friedman test. Friedman test is a non-parametric alternative to the one-way ANOVA with a repeated measure. It is used to test for differences between groups when the dependent variable being measured is ordinal. It can also be used for continuous data that have violated the assumption necessary to run the one-way ANOVA with repeated measure. For example, data has marked deviation from normality. Friedman test is commonly used in two situations. First one, measuring the mean score of the subject during 3 or more time points. The next situation that we can use for Friedman test is measuring the mean score of subject under 3 different conditions.
For non-parametric statistics like study case 2, is used to test the hypothesis. There are 5 steps in testing hypothesis. Firstly, state the null hypothesis and alternative hypothesis. Secondly, Calculate the test statistic with generating the contingency table that have two variables. The calculation is based on observed frequency and expected frequency. Thirdly, determine the critical value of the statistic. Fourthly, check the assumptions for the test, and finally, perform the test and draw the conclusion. If the value thus computed for the given degrees of freedom and level of significance is lesser than the critical or tabulated value, accept the null hypothesis. If not, reject it.
Good evening to everyone. My name is Edward. I'm here to express one of the example of the fragment test. Below is the example. Department of Public Health and Safety wants to ensure whether the measure taken to clean out cleaning water from trihalometane were effective. In this research, 12 countries are involved, and the period for inspection is before the clean out, 1 week later, and 2 weeks after the clean out. We need 6 steps to answer the question. Firstly, we have to state the null hypothesis, that is, there is no significant difference of trihalomethanes in drinking water before clean out, 1 week later, and 2 weeks after clean out. And because the fragment test is about the medium of the data, we have to state that the medium among 3 time periods is the same. On the other hand, the research hypothesis would be there is a significant difference in trihalomethanes in drinking water during these periods. Next, we have to state the level of significance as alpha equals to 0.05. Then we can proceed to the ranking of the data. A special procedure is used, which this procedure is going to involve us actually looking at the values only in their respective block. And the greater the value, the higher the ranking. We should just provide ranking to this value accordingly. For instance, we look at the first country, the before clean out category would have the greatest rank for 3, 2 for 1 week later, and 1 for 2 weeks after clean out. The following country will apply the same ranking method, and so on. The total ranking value are summed out to their respective time period, which is 35, 24, and 13 respectively. We apply this equation for testing statistic. Q equal to 12 divided by nk, and n plus 1 multiplied by the total sum of square ranking, and reduced by 3n k plus 1. This might sound complicated, but in this case, we just have to remember that n is the number of the country, while k is the time period. Therefore, Q is equal to 20.1667. The very last thing is to compare both the calculated value and the critical value before making a conclusion. The degree of freedom is 2, hence based on the chi-square distribution table, the critical value is 5.9915. Since the calculated Q value is greater than the critical value, the null hypothesis is rejected at 5% significant level. This result shows that there is a significant difference in trihalometane in drinking water during these periods.
Assalamualaikum and good afternoon everyone. Today we are going to discuss what is regression analysis and correlation analysis. Regression analysis is to examine where the changes or differences in values of one variable, dv dependent variable y, are linked to changes or differences in values of one or more variables, independent variables, while controlling for the changes in values of all other x. Next is correlation analysis. It is a statistical measure which shows relationship between two or more variables moving in the same or in opposite direction. The sample correlation coefficient R measures the degree of linearity in the relationship between X and Y. Next, we will discuss how to answer regression-based questions step by step. Steps number 1. State the null and research hypothesis based on the questions given. Step number 2. Insert all the values given into Excel to calculate it using analysis toolpack. Step number 3. Observe the value of R and state whether it is a weak or strong correlation. Next, step number 4. Observe the value of R squared to determine how well the data fit the regression model. Step number 5. Compare the value of F with the value of significant F. Last but not least, make a decision whether to reject or accept null hypothesis based on the observation we made.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamed Zafri and I will explain about the example from the case study 3, which is regression and correlation. The question is, cigarette smoking and cancer have been linked. The number of deaths per 100,000 from bladder cancer and the number of cigarettes sold per capita in 1960 are in the following table. Using analysis toolpath, show your finding. State the hypothesis testing of this study and interpret the finding of the analysis. First, let's state the hypothesis from the question. For the null hypothesis, there is no significant difference on the number of deaths per 100,000 from bladder cancer and the number of cigarettes sold per capita in 1960. Then, for the research hypothesis, there is significant difference on the number of deaths per 100,000 from bladder cancer and the number of cigarettes sold per capita in 1960. Next, I will show you how to calculate the data using analysis toolpath. First, I arrange the data in vertical order. Then, find the data analysis toolpath, click regression. And for the input Y, we will drag the right column here. And for the input X, we will take the left column here. Then click label and output range we will put anywhere. Click OK. And this is how we calculate regression using analysis toolpath. This is the clear image from our calculation by using analysis toolpath. From the result, now we can interpret the data. For the correlation, R equal to 0.7034. which is moderately strong correlation. For the R square is equal to 49.47%. It is poor linear relationship between cigarette sale per capita and bladder cancer death per 100,000. Therefore, no variation in bladder cancer death per 100,000 is explained by variation in cigarette sale per capita. For the significant F value, which is 41.1223, is higher than significant F value, which is 0.00, while the P value is lower than alpha level, which is 0.00 lower than 0.05. Thus, the null hypothesis is rejected. For the coefficient in this simple linear regression, the coefficient for the cigarette sale per capita have the sign of the bladder cancer death per 100,000, which is 0.122. And lastly, for the residual is equal to 0.4817, which is near to 0.
Assalamualaikum and hello. I'm here to summarize all the tests that are used in this presentation. The first test used is chi-square test. Chi-square tests are used to find the relationship between the categorical variables. It's also function to compare the observed result with the expected result. Unfortunately, chi-square test can only be used on frequency data. The second test used is Friedman test. Friedman tests are used for one-way repeated measures analysis of variance by ranks. Moreover, it also compare the mean rank between the related group and indicate how the group differed. It should only be used on continuous variable of interest and have 3 or more groups. The third test used is correlation and regression test. Correlation tests are used to show the relationship between the two variables, while regression tests are used to show how one variables affect the other variables. That's all from us. Thank you for watching our presentation.